Hi guys, in this video I'm going to go through with you Additional Mathematics SPM Trial paper for year 2021 for Selangor Set 1 paper 1. My name is Terry, I'm an MS specialist. So let's begin with the first question. So in the first question, question 1, you're given gx and this gx is equals to ax plus b over cx plus d. Now, given that x cannot be equals to k. So you're supposed to express k in terms of c and d. And then hence we find g inverse x. Okay, so first of all, we know that a function is undefined if your denominator is equal to 0, right? So in this case, your denominator is cx plus d, and we'll let it be 0. So if I make x subject, I will have to bring the d over. So I'll get negative d, and x is now minus d over c. So normally we call this a rational function, a function with a fraction here. If you have a rational function here, and then we have denominator involving x. Now we let this be 0, and then we state the x value that cannot occur, because we know that if x equals to, in this case, negative d over c, when I sub inside, the whole thing becomes 0 here, and any number divided by 0 is undefined. For example, you have 2 divided by 0 is undefined. So normally, after writing the function, we will have this expression here. We write x cannot be equals to k. And in this case, this k value is the same as your negative d over c. So we write k is negative d over c. Yeah. So that's how you express k in terms of c and d. Okay, next, we are supposed to find g inverse. Okay, to inverse a function, I just want to let you all know, because there are two versions to it, right? Most of the time, the textbook will let g inverse x equals to y. So you need to do this, right? Then you have, the textbook will let gx equals to y. If you to do this, you will need to make x as a subject, right? But personally, I like to use the second version, g inverse x equals to y. That is, I need to make y as a subject. But when you do this, remember, we have to interchange gy is now x. Is that, for example, when you start with x, we go backwards, g inverse x. The outcome is now y. So when you move forward, we say gy, your object is now y, your image is now x. Yeah? So we just interchange the object and image. Now, your gy is, if your gx is ax plus b over cx plus d, your gy will be ay plus b over cy plus d. Basically, you replace your x with y. Now, we let this whole thing equals to x. Now, if you're solving for g inverse x, that means you're finding y. So to find y, we need to multiply this over first. Ay plus b equals to cxy plus dx. We need to make y as a subject. So I bring this over, bring the b over. So ay minus cxy is now dx minus b. Factorize your y, you get a minus cx equals to dx minus b. So when you divide this, your y is now dx minus b over a minus cx. Now, in this case, we can say that your y is your g inverse x, and the outcome is dx minus b over a minus cx. Okay. All right. So that's how you get g inverse x, and your answer will be in terms of a, b, c, d. Okay. Now, one thing I have to take note, if you notice that what actually happened here is that your d and a actually change position. Now, maybe I will rewrite this again. I write minus cx plus a. So I just want you to compare your original function gx is ax plus b, and this is cx plus d. Now, I want you to look at the changes here. A and b actually changes position. B and c actually has a negative in front, right? Can you notice that? Now, I hope you remember in your mock maths, the chapter called matrices. Yeah, if I have matrix A equals to A, B, C, D, your A inverse is 1 over the determinant, which is AD minus BC. But more importantly, your A and D actually change position, and your B and C, we put a negative in front. So in a way, this is very similar to matrices. You can see when you inverse a function, D and A actually change position, B and C, we add a negative in front. Okay, knowing this, we would be able to do part B. So they say, using the function G inverse obtained, determine G inverse X for each of the following function. So number one, we need to identify, let me do Roman 1 here. We need to identify our A, B, C, D. So you can say my A is 7, right? My B is -4. My C is 2. My D is -3. So my G inverse will be, remember, we interchange the position of D and A. So I put a -3x. All right, I'm going to put a +7 here. I put a negative in front of B and C. So this is going to be a +4. This is 2. So you put a negative in front, becomes -2x, right? If you want to show, you can refer to this formula here that we got earlier in part A. All right, so there you go. We got this answer. Now, normally, if you have negative in front, right, of x, right, so we just rearrange it. We put 4 minus 3x, all right, and then you divide by 7 minus 2x, okay? If you don't arrange it, it's okay. It's just that it looks better. Usually, we put a negative at the back. We keep the positive in front. Okay, Roman 2. Now, for Roman 2, my A is now 2. My B is now -3. My C is now 1. And my D is now -5. Again, I would need to interchange the position of A and D. So I put D first, -5x. I put A at the back. For B and C, let's put a negative in front. So B itself has -3. So when you put a negative in front, it becomes +3. As for C is positive, you put a negative in front, it's -1x. I don't have to write 1. So it's just -x. Then again, it's better to put the negative at the back, leave the positive in front. So this is 2 minus x. Yeah. Okay, of course, it's a good habit to write your denominator here. If you anytime you have a denominator that is involving x, so we have to write here x not equals to 7/2. Second one, x not equals to 2. Remember, we let our denominator be 0. Your denominator here is 7 minus 2x. Mentally, we let this be 0, right? Bring over. 2x is 7, x is 7/2. So we write x cannot be 7/2. Likewise, for the second one, our denominator is 7 minus 2 minus x. We let it be 0. X equals 2. Right here, x cannot be 2. All right. Okay, now let's look at part C. This is very interesting. If C is non-zero, what is the condition on A and D such that G is equals to G inverse? Okay, so here's the thing. We're not actually solving for x. We're finding what are the possibility. Yeah, what are the condition, if you like, what is the relationship, if you like, between A and D such that a function is the same as its inverse. Now, we know from the earlier one that my gx, you can see from here, my gx is ax plus b over cx plus d. My g inverse is dx minus d minus b minus cx plus a. So I'm going to equate them here. I'm going to equate them. So I'm going to write my gx is ax plus b over cx plus d. My g inverse is, remember, we interchange the position of d and a. So this is dx, put a negative in front of b, put the negative in front of c, and then this will be a plus a. Now, it's kind of difficult to compare them if they don't have the same coefficient. You see, c here is positive, but c here is negative. B here is positive, but B here is negative, right? So if they are actually equal to each other, I need to make C the denominator or the numerator, both of them has the same figure. So what I'll do is I'll take out the negative, or should I say multiply top and bottom by -1, right? You can actually do that, multiply top and bottom by -1 so that we don't change the value of the expression. So when I multiply this, your D, this is now negative dx, this is plus B, this is now positive cx, this is now negative a. So we're going to compare ax plus b with a cx plus d now. Okay, now notice when you compare, right, this a is actually the same as negative d. And this d is now the same as negative a. Because your cx are the same, b and b are the same. So here we can conclude that by comparison, a is now negative d. So that's the condition. The condition Yeah, what is the condition? In order for the inverse and the function is the same, well, your a must be the same as your negative d. Now you can do the other way around. You can say, oh, my d equals to negative a. Can either way, yeah, either a equals negative d or d equals to negative a. All right. Okay, moving on to question number 2. This is quadratic inequality, chapter 2. All right, so you're supposed to find the range of values of x, right? For which these two inequality are valid. Yeah. So first, I think for the first one, we're going to write, I'm going to rewrite here 2x squared plus x plus 4 more than 5. Yeah, 5 less than this, or we can say this thing is more than 5. Rearrange it, bring it over to the left-hand side. So this is 4 minus 5, which is minus 1. Now let us double bracket factorize this. So what is your factor here? 2x, x, 1, 1. In order to get 1, this should be a plus 2. This should be a minus 1, right? So your roots will be half and negative 1. But since this is a quadratic inequality, we have to sketch a graph to solve it, right? Your x is now negative 1. The roots are negative 1.5. So remember, to solve linear inequality, we normally, what we have to do is we look at the whole thing as your y. This whole thing is your y. And I want my y to be more than 0, right? So y is more than 0 if it's above the x-axis. We know at x-axis, y is 0. Above the x-axis, y is more than 0. When your y values are more than 0, your x value must be here and here. So we can conclude that your x must be less than negative 1 or more than half. Okay. Now, if you look at the second inequality is 2x squared plus x plus 4, and it's now less than 10. So similarly, we have to solve them, right? I need to bring it over. 4 minus 10, negative 6. Double bracket factorize it. Let's take 2 times 6. 2 times 6 is 12, factor of 12. In order to get 1, I should use 4 and 3. So meaning this is 2x, this is x. I need to get 4 here. I put a 2. I need to get a 3 here. I put a 3. Your final answer is a positive. So the bigger number 4 is a plus. Smaller number 3 is a negative. So it's a plus 4 minus 3 gives us plus 1. So my x value is between, in this case, minus 2 and 3/2. So less than 0 means your region should be below here. We move it up. And then we know that your x, in this case, is in between minus 2 and 3/2. Okay, I want to say again, remember, when we want it to be less than 0, your y value should be less than 0, right? Your y is equal to 0 at x-axis. Below x-axis, your y value is less than 0. So whatever values here around here, your x value around here, yeah? In fact, between minus 2 and 3/2, your y value is going to be less than 0. Okay, I'm not done yet. I still need to combine these two inequality because we have the first inequality, right? And the second inequality. So we want to combine it and solve this. Look at this. This is actually a combination of both first inequality and the second inequality, right? So the first part, they ask us to find the range of value for the first inequality, second inequality, and then solve for this. Okay, we know that this is actually consists of these two. Then to combine them, we normally use a number line. So when you use a number line, just map out all 4 values. The first one is minus 2, second one is minus 1, third one is 1/2, last one is 3/2. Okay, so this is a number line. I know x for the first one is less than negative 1 and is more than half. For the second part, your x is between minus 2 and 3/2. Remember, it's non-inclusive. Non-inclusive means you don't blacken it, or should I say shade it, right? So we just leave a circle. And once you combine them, you can see the range of values of x must be between minus 2 and minus 1. And the second one is between half and 3/2. Okay, let's move on to question 3. This is indices and logarithm. The first part is indices. We're supposed to solve for x and give your answer in this form. So number 1, we have x on the left and on the right. We're going to bring this to the left-hand side. So square root 7x. Let me write square root 7x minus square root 2x. The result is square root 3. So let's factorize this as square root 7 minus square root 2 bracket x. Your outcome is square root 3. So to find x, let's divide them. Square root 3 divide square root 7 minus square root 2. Okay, now I can't divide directly because we have to rationalize the denominator. We need to simplify this further. Now, the method in which we rationalize the denominator is that we have to multiply top and bottom with what we call a conjugate, right? A conjugate of square root 7 minus square root 2 is square root 7 plus square root 2. Yeah, it's the opposite if you like. Okay, the twins if you like. So you multiply top and bottom with the same thing so that we don't change the value of the whole expression. Now, the next thing is when you multiply this inside, square root 3 times square root 7, we can put them together as square root 21. Square root 3 times square root 2 is just square root 6. All right. Now, the next thing is your denominator. Please think in terms of a plus b, a minus b. In this case, I put a minus first, that doesn't matter. So a minus b, a plus b. When you expand, is a squared minus b squared. So I need to square this, right? So I have to put square root 7 square, which is 7. Square root 2 square is going to give us 2. Answer square root 21 plus square root 6 divide by 5. Right? So there you go. That is the first part. Okay, moving on to the second part. Okay, so you're finding the value of p that satisfies the following equation. So this question is very interesting because you have to use you have to change the base of logarithm, right? When a lot of people look at this and wonder, hey, what do I do with this, right? So this is base p, this is base q, this is pq, pq. Now, if you don't have the same base, it's a problem, right? We cannot combine them. We can combine it only if they have the same base of logarithm. Now, there are two versions of changing base. The first version, the basic one, is when you change the base of the logarithm, we can introduce a new base, let's say c and c, original number b right on top, original base a right below. This is one. Now, the second version is this. What if I use base b? For example, instead of using c, I write this as log b, okay, log b, and original number b stays on top, original base a stays down. Now, log bb actually has the value of 1, so we can just leave it as 1. All right, so what I'll do in this case is that I will change both of them to the same base, which is base pq, right? Okay, so to change the base pq, we need to do 1 over, let me write over here. This is 1 over log base pq. This new base is pq, the new number is now b. So notice I actually interchange a and b. So a becomes a number, b becomes a base. Now similarly, pq becomes a base, p here becomes a number. Then you continue with the second one, 1 over log base, your base now pq, your number is now q. And you add with 2, the result is 6p. Okay, now when you take the number divided fraction, like 4 divided by 1 over 3 is the same as 4 times 3 over 1. You all know that, right? So I just flip it up. So likewise, I'm going to flip up for both. I flip this up, I get 4 log pq(b). I do the same for the second one, 4 log pq(q). I plus 2, the result is 6p. Okay, now we can actually combine this, factorize it, take out the 4 log pq b log pq q, and plus 2, the result is 6p. Now, in the logs of logarithm, we know that if I have log base ax plus log base ay, when you combine them, the outcome is log base ax times 1. So that's what I'm going to do here. I'm going to put log base pq, p times q, which gives us pq. And you plus 2, the result is 6p. Okay, so what happened to this? Log pq. Well, we know log AA is 1. We know log AA is 1, right? A power 1 is A. So log pq is also 1. So now you're left with 4 times 1. Then you plus 2. gives us 6. So 6 is 6b, b is 1. Yep, very interesting question. Okay, let's move on to question number 4. Okay, this is chapter 3 from 4, chapter 3, system of equation. Yep. So the first part, determine whether the following equations are linear system of linear equation in 3 variable or not. Okay, so we know if it's system of linear equation in 3 variable, normally we have x, y, z, and all the terms must be linear. So linear means x, y, and z, they must have power 1. Now notice, look at the second equation here. All right, this is not power 1. Huh? When you multiply a variable with another variable, it's going to be a non-linear variable. So how do you explain your answer? We say equation, we can write here, equation 4xy plus 2z minus y equals to 10 has non-linear term 4xy. Yeah, 4xy is a non-linear term, right? Or you can say 4xy is a, you can say this equation is non-linear equation. All right, so let's move on to B. Solve the following linear equation. Oh, so when it comes to solving, right, you have two ways that we can solve by using elimination or substitution, depending on which one is easier. Now, when I look at this, right, equation 1, equation 2, equation 3. My equation 1 has no z. My equation 2 and 3 has z. But the z values they have the same coefficient. So it's actually easier to first get rid of z by using elimination. You can take equation 2 minus 3. You can even use 3 minus 2. Okay, so here since equation 3 is bigger, I can see 4x is bigger, so I'll just take 3 minus 2. By the way, you can do 2 minus 3. Yeah? So 4x minus 2x is 2x minus 7y minus 3. Okay, if you're not sure, you can write like this, minus 7y minus 3y. So this is going to give us minus 4y. The 2z minus 2z disappear. 6 minus 2 is going to give us 8. Okay, before we, try to solve this by elimination further, now just notice that this equation has 2x, this is 4x. Well, if I want to solve for them, right, I want to solve this, right, I need to simplify further. That is, I can take this equation, I just divide by 2. So x minus 2y is now 4. Oh, notice that equation 1 and equation 4, they are actually the same equation. So the concept behind this, if today I were to sketch this graph, right, this straight line graph, you can bring over and say 2y equals to x minus 4, y is half x minus 2. That means it's a straight line graph with the gradient of half and y-intercept of -2. So this is your first line, right? Your first line is x minus 2y equals to 4. Now, however, my second line here, equation 4, it is also the same line. Okay, it has the same equation. Therefore, it has the same line here. They are actually overlapping, right? So when they overlap, how many number of solutions would I have? Answer is infinite number of solutions. But normally what we do is we can, the moment we show that they are same equation, right, we have to solve them by elimination. Again, we take equation 2, equation 1 minus equation 4. Look at equation 1 is x minus 2y equals to 4. Look at equation 4, x minus 2y equals 4. So when you subtract 4 minus 1, 1 minus 4, doesn't matter. All the x will cancel out. So your left hand side is 0. 4 minus 4 is still going to be 0. Your y cancels out 0. Huh? So you get 0 equals 0. So the main thing is 0 equals 0 simply means because both lines are overlapping. When they overlap, you have infinite number of solutions. So just write this as your answer, infinite number of solution, right? Okay, question number 5. Now, the first part is very interesting. Yep, a recent SPM question also, they started test student on deriving the formula. So this is one example, yeah, of deriving the formula for geometric progression. And remember this chapter 5, arithmetic and geometric progression, they're under the chapter progression. Okay, the first part, you are given a geometric progression with this term. and the sum of the first n term is this, Sn. So we're supposed to derive the formula for Sn. Okay, we know Sn equals what? Sum. Sum means A plus second term AR, third term AR square. You don't have to write all. I just write, follow what they have up to AR3, dot, dot, dot. The second last one, ARn minus 2. The last one is ARn minus 1. So to derive this formula, I need to get rid of all the terms in the middle. Now you notice that if you take equation 1 multiplied by r, here you get Rsn. If you take your a, you multiply by r, you get ar, which is the same as the second term. If you take your ar, you multiply by 1r, you get ar squared, which is the same as the third term. And so on. This is ar cubed. This will be ar4. And if I take ARn minus 2, if you're not sure, Rn minus 2, you times with R. R means R power 1. You get n minus 2 plus 1, which is Rn minus 1. So what I'll be getting is the same as this term here, the last term. Okay, how about ARn minus 1? When you multiply by R, you get ARn, equation number 2. Yeah, let me say this again. ARn minus 1. You multiply by r, r means r power 1, you get r power n, no more -1. So once you got this, the next thing is I want to get rid of all the terms in between. So we'll take equation 2 minus equation 1. Now, normally when you say for modulus r more than 1, we are referring to r more than 1 or r less than -1. So normally that's the case, right? We take the second equation minus the first equation. So reason being, it's going to give us a positive value, because if your r is bigger than 1, right, when you minus with this, it's going to give us a positive value, right? Okay, like for example, r is 2, 2 minus 1 is going to give us 1. Okay, when you subtract your ar, let me show you here, ar is going to cancel with this ar. Your ar squared is going to cancel with this. Ar cubed is going to cancel with this. Now ar4 is going to cancel this term here, not shown. Arn minus 1 is going to cancel with this. The term before Arn minus 1 is going to be Arn minus 2. So you're going to cancel this. So what we have left is the first term of the equation 1 and the last term of equation 2. So since we are taking 2 minus 1, so I'm going to write Arn minus a. So these are the two leftover terms. All right. Since I'm finding Sn, so I'm going to factorize my Sn, take out your r. Take out your Sn, you're left with r minus 1. For these two, when you take out your a, you're left with Rn minus 1, dividing them with r minus 1. So you have Arn minus 1 over r minus 1. There you go. That's how you derive the formula. All right. Let's move on to part B. Now, hence, find the value of n for which the sum of the first 2 n terms is 28 times the sum of the first n term for a geometric progression with a common ratio of r. So we know in this case, sum of the first 2 n term is 28 times sum of the first n terms. Now, you know your common ratio, but we do not know your first term, and we want to find n. So now your first term is okay, we'll leave it here, a, right? This will be r, which is 3 power 2n minus 1. Remember, the formula you can refer back is a Rn minus 1 r minus 1. But instead of using n here, or n here, we use 2n, right? This is, your n is now 2n. You replace with 2n. This is 3 minus 1. And this is 28 times of a, r, your r is 3 power n minus 1, 3 minus 1. Now the good news is we can cancel them, right? You don't even have to calculate. This one you can cancel, which is 2. This one you can cancel, right? So you're left with a 28 there. Now, what we can do is to simplify this 3 power 2n minus 1. This is 28, 3n minus 28. Now, at this stage, some students find it a bit hard to see it because you have a 3 power n and 3 power 2n. So what you can do is we can use substitution to simplify this equation and then solve it. As in, we let 3 power n becomes, let's say, u. You don't like u, you can use y or x. So when you have 3 power 2n, it's going to give us u squared, isn't it? Or if you can't see it, let me just write. Your 3 power 2n is actually 3 power n squared. So this is just u squared. So by replacing the first term here with u, this is going to give us u squared minus 1 equals 28u minus 28. So what we have here, let me continue over here. What we have here is a quadratic equation. Yeah, bring the negative 27 over, bring the 28, bring the 28 over, bring the this negative 28. When you bring this over, is minus 28u. This is positive 27 equals 0. 28 minus 1 is 27. So let's double bracket factorize and solve for u. This will be u 27 1, and both are minus. To get negative 28, this must be minus 27 minus 1. So my u is 1 and 27. And remember, u is 3 power n. So we're going to replace it back, 3 power n, 3 power n, right? Now we know anything power 0 is 1. So 1 is 3 power 0. By comparison, n is 0. And the second one, 27 is 3 power 3. By comparison, n is 3. However, please take note. Your number of terms n, can it be 0? Can your n be 0? 0 term, what is the 0 term? N equals 1 means the first term. N equals 2 means second term. 0 term doesn't make sense, right? So we know n must be more than 0. So we take n equals to 3. Yeah. So only one answer. Okay, next question. Let's look at number 6. This is linear law. Very interesting question. Chapter 6, called linear law, form 4. Okay, now diagram shows part of the graph y against x for the equation y equals to p power x cubed such that p, q are constant. So you're supposed to sketch the graph of log base 3y against x and mark and state the coordinate of corresponding point A and B. Okay, so the first thing is we need to recalculate this. I remember this is y versus x. So when your x is 1, let's say we start the first point at 1 and 9. Your y is now 3. So what is your log y? Your log base 3y. If I put log 3, 3, log 3, 3, I replace y with 3, the result is 1. If my x is 3, look at the second one, your x is 3. Your y is 27. So your log base 3y becomes log base 3, 27. Well, this is 3. 27 is 3 power 3, but you're not sure, right? You can actually use a calculator. This calculator, you can actually cheat, right? Log 327. This is 3, right? So we know it's 3 power 3. That gives us 27. So we got these 2 points now. Now, you're supposed to sketch the graph. So I'm going to sketch the graph like this. So this is my horizontal axis, which is x. My vertical axis is log base 3y. Remember, you're supposed to sketch the graph of log 3y against x. So we have 2 points. The first point is 1, 1. Okay, 1, 1. Maybe I would just write 1, 1. Okay, I think I made a mistake here. This is log 3, 9. This is 9, sorry. This is 9. This is log 3, 9. And this is now 2. Sorry for the error. I wrote wrongly. This is 9. Y equals 9. Log 3, 9 is 2. You can double check. Log 3, 9. This is 9 here. There you go. 2. So your coordinate is 1, 2 here. This point here is 1, 2. This point here is 3, 3. All right, I need to plot 1, 2, let's say around here. Maybe make it a bit bigger, taller here. This is 1, 2. 3, 3 should be a little bit higher somewhere here. 3, 3. Okay, maybe a bit, let's make it a bit closer. It's still too far here. Okay, 1, 2, 1, 2. And 3, 3. 3, 3 should look further like this. Yeah, this is 3, 3. So join together. This is your first point, point A, point B. Yeah, initially your this is point B, sorry. This is point A. A initially is 327. When you convert to log 3 y, it becomes 3. B initially is 1, 9. When you convert it, it becomes your log 3y, it becomes 2. So this is your straight line AB after you convert to linear form. All right, next we are supposed to calculate the value of P and Q. Okay, actually there are many ways you can do it, but I would prefer to use the linear law method. So since we convert it to linear form, so to use the linear law method, we need to find two things. We need to find the gradient, we need to find the y-intercept. Okay, let's start by finding the gradient. My gradient is y2 minus y1, x2 minus x1, which is 1/2. Okay, now my y-intercept, we can use y equals to mx plus c, right? We just sub any point inside. Remember, y equals mx plus c, we sub 1 and 2. My y is 2, my x is 1, my c is 2 minus half, which is 3/2. So once you got the value of c, I can rewrite now, y is now half x plus 3/2. But here's the thing, we need to find your value of P and Q, right? You're supposed to find P and Q here. All right. Now, your P and Q is the constant here in this equation. So maybe you can either sub in your log 3y inside and convert back to linear form, a non-linear form to this, or we can start from this equation, convert to linear form. Now, personally, I think the easiest thing for students to do is to take this original function here, this one here, convert this to linear form. So we can do that by writing log base 3y. Basically, I'm introducing log on both sides of the equation. Put log 3 on the left, put log 3 on the right. It's easier that way. So I don't want to write y equals mx plus c. I already know my gradient. I know my y-intercept. I convert this to linear form. Okay, in logarithm, remember, when you break up plus times, break up becomes a plus. You bring the power x down. So this is x log base 3p. This is log base 3q. I just have to rearrange it. Put log base 3p in front, put the bracket x. Now remember to put this because if you don't put the bracket, this one means different thing. This means you take p, you multiply x, then you take the logarithm. Right? It's different thing. So that's why I need to split them first. You have to put a bracket and then log base 3q. So this is now your big y. This is now your m and your x and your c. Okay, I just need to compare my gradient from the equation with the gradient that I got from the graph, which is half. Okay, by changing from logarithm form to index form, remember, if I say log ay equals to x, your y is now a power x. So p is 3 power half. You can write this as square root 3. Okay, and likewise, if I compare my y-intercept, my log base 3q is now 3/2. Your q is 3 power 3/2. I'm using this here. Now 3 power 3/2, 3/2, right? You can actually change it to 3 power 1 plus half, 1/2, which is 3 power 1 and 3 power half. 3 power half is just square root of 3, right? So we can leave our answer as 3√3. Now, it's okay to leave it as 3 power 3/2. Yeah, so both are still fine. Okay, so there you go. Your P is sub 3. Your Q is 3 sub 3. Okay, moving on to question number 7. This is coordinate geometry. Okay, coordinate geometry. So diagram shows a trapezium, right? A, B, C, D. The equation of straight line AB is 2y minus x equals to 1. AD is a height trapezium. Okay, so I think one thing that is not mentioned in this question is that, or they didn't mention that this is perpendicular. Because understand that when two lines are parallel, right? Yes, it forms a trapezium, but your trapezium may not necessarily be perpendicular here. This one is not necessarily perpendicular, right? Trapezium, yes, the perpendicular, this is a perpendicular distance. The two lines are parallel. This one is a perpendicular distance. But this line AD may not be perpendicular. It's not stated. Maybe they missed out in the diagram. It's supposed to be 90 degrees, right? Okay, so you're supposed to find the value of P. Now, number one, we know if they're trapezium, these two are parallel. So we can find the gradient of AB and gradient of DC. Well, equation of straight line AB is already given as 2y minus x equals to 1. So to find the gradient AB, we just change this to y equals to mx plus c. My y is now half x plus half. My gradient of AB is just half. Okay, for DC, my gradient DC, I like to use y2 minus y1 divide x2 minus x1. So we can simplify this to 1 over p minus 4. All right, so since these two are parallel, so they must have the same gradient. So we can just compare. Half equals to 1 over p minus 4. So 2 equals to p minus 4. I can just compare directly at the denominator. Since the numerator are equal, my p is 6. All right. Now next, how do you find coordinate point A? Well, before you find coordinate point A, you notice we know this equation, 2y minus x equals 1. The problem is I don't know the equation of AD. I do not know equation of AD. So to find equation of AD, I must first find the gradient. Now we know AB and AD are perpendicular. See this? Yeah, perpendicular. So for part B, we're going to start with gradient AB times gradient AD. Remember, when two lines are perpendicular, your gradient M1 times M2 must be -1. So here we find gradient AD. AD is -2. And if straight line AD passes through point D, we can form the equation. Now here I'm going to use this formula, y minus y1 mx minus x1. Now you can also choose to use y equals mx plus c, right? So my y1 should be a point that passes through, which is point D. My gradient is -2. My x1 is 4. So y plus 1 is minus 2x plus 8. Bring it over minus 2x plus 7. Yep, this is your equation. Okay, remember, if I know this equation and I know this equation, both of them actually meet at point A. And to find the point of intersection, I have to solve them simultaneously. So let's call this equation 1, call this equation 2. Let us sub equation 2 inside equation 1. So the moment I sub inside, okay, what's my y? Minus 2x plus 7. U minus x, the result is 1. Minus 4x plus 14 minus x, the result is 1. Minus 5x, if I bring this over, is minus 13. This is a quite an ugly number, I must say. So 13 over 5, right? So once I got 13 over 5, we can now sub inside, let's say, equation 2. My y is minus 2, 13 over 5 plus 7, right? So this one you have to use, you can't use brain, you use calculator. It's actually minus 26 plus 35 over 10, which is going to, over 5, which is going to give us 9 over 5. Yeah, this is 5 here, 9 over 5. Huh? Okay, if not, you can use your calculator. Just key in your calculator. So your coordinate of point A is 13 over 5 and 9 over 5. All right. Okay, question number 8. Okay, this question is, the first part is okay, but the second part is a bit weird. I'll explain to you why this question is a bit weird, okay? All right, so first of all, you have a triangle here with vector OP is 5x, vector OQ is y, and OR is 3 over 5 OP. So for me, if I see 3 over 5, I would straight away put OP as 5x, and I know this is 3x. Yeah, by the way, this is R. My R looks a bit ugly. So this will be 3x. The whole thing is 5x. So this will be 2x. I'll label the diagram easier to see. So I can just read directly from the triangle. Now, your OQ is now y. And your given PS is 2/3 of PQ. So that means this is 2. The whole thing is 3. This is 1. Okay, the first part, I want to find vector OS, okay? So I want to go from O to S, we can go directly here, okay? We can go O to P, P to S, okay? So let me write down, OS is O to P, P to S. OP is just 5x, PS is 2 over 3 of PQ. So we are going to sub in your PQ. Your PQ, we can use OQ minus OB, or we can just go directly. Yeah? Let me show you here. PQ means we go B to O to Q, which is minus 5y, minus 5x plus y. Okay, let me just show you here. Minus 5x plus y. Okay, when you multiply this inside, this is 5x minus 10 over 3x plus 2 over 3y. 5, you minus 10 over 3 is 5 times 3, 15. 15 minus 10 is 5 over 3 x plus 2 over 3y. So there you go. You got OS in terms of x and y. Okay. Now, next part, you're finding unit vector in the direction of RS. Okay, let me explain. Let's find RS first. Okay. Now, for me, it's actually easier to go R to O, O to S, because I already have vector OS. Yeah. R to O, O to S. Let me just write this. RO plus OS. RO is opposite. I'm going negative 3x. And my OS already have it here. 5 over 3x plus 2 over 3y. So this result is 5 minus 9, which is negative 4 over 3x plus 2 over 3y. You can't do mentally, please use your calculator. Yep, it's not difficult. Okay, now the problem is this. How do you find unit vector in the direction RS? Okay, here's the thing that a lot of people don't understand, don't know, right? Unit vector is predominantly used in IJ. Why? Because if you want to find unit vector, let's say vector R is xi plus yj, your x and y, they are perpendicular to each other at any time. For example, this is xi, this is yj in ij form. Your magnitude is given, magnitude of vector R is just x squared plus y squared squared root, because this is the length. So unit vector of R is given xi plus yj divided by this. Now, this square root x squared plus y squared is a Pythagoras theorem. It's based on the fact that this is a right angle triangle. X and y, they are perpendicular to each other. Correct? Now, here's the problem. Is x and y perpendicular to each other here? Now, look at your diagram. Look at your diagram. X is going slanting, y is going horizontal. They are not perpendicular to each other. So you can't be taking this and divide by the magnitude, right? Okay, if you want to find the magnitude, question, how do you find magnitude RS? Okay, let's just join this together, okay? Let me just join RS together, okay? Now, we know RS is minus 4 over 3x plus 2y. That means, let me use a blue color pen, a different color pen. Okay, this one. I'm supposed to go this way, followed by this way. This, the red one, the red line here is going negative 4 over 3x. The red line over here, horizontal, is 2 over 3y. If you want to find unit vector, you must take this vector, divide by the magnitude. The magnitude is this length, RS. Now, my question is, okay, number one, are you given vector, the magnitude of x? No, the question didn't give us the magnitude of x. Are you given the magnitude of y? No, the question didn't give us magnitude of y. Now, in triangle, if let's say, even if I'm given the magnitude of x, let's say, example, my x is now 3. So this will be 4 over 3 times 3. This magnitude is 4. Now, y appears to be a lot longer. You can see here, y is a bit longer. Maybe I say y magnitude y, let's say, is 9. So 2 over 3 times 9. 2 over 3 times 9 is going to give us 6. Okay, even if I know this is 4, this is 6, I know the magnitude. Can you find this thing? RS. No, you can't. Why? Because you don't know this angle. Well, unless I know this angle. Okay, this angle is given. Okay, angle between them is 45 degrees. Can we find RS now? Yes. We use cosine rule. Remember, RS is 4 squared, 6 squared, 2, 4, 6, cos 45. Then I can find, there's a square here, then I square root it, and I find RS. Then I got a magnitude RS. Then I take this vector, I divide by the magnitude. So that's the problem. Yeah, the first problem is the magnitude is not given. And the second problem is some people think that, oh, I take this one, I divide by the magnitude, that's it. No, because unit vector, remember, usually based on the fact that I and j are perpendicular. When they're perpendicular, we can use Pythagoras, x squared plus y squared square root. Now this is not perpendicular. You can see x is going this way, y is going this way. They're definitely not perpendicular, right? So if you want to solve it anyway, you need to know this angle. Like example, they give us this angle 45. They must give us the magnitude. Then we can find the length of RS. Then we take this vector divided by magnitude, which is super long, right? So I guess maybe what you can do is just find vector in the direction of RS. All right. So alternately, what they can do is they can give us, okay, what is x? Maybe x, they give us the direction of x. Okay, x equals to, let's say, I'm going this way up. Okay, let's say my x is I plus 2j. And then my y is going to the right. My y is, let's say, 3i. Yeah, y is going there. Then you have to sub inside, simplify, then you find unit vector. Okay, that is possible, right? If you're given vector x in terms of ij, vector y in terms of ij, we sub inside, we simplify, then we find unit vector. Yes, that is possible. I hope you understand my explanation. Okay, so question number 9, next one. Okay, so now, diagram shows a circle with center at point O, origin of a, O is origin of a Cartesian plane. So straight line BOC is the diameter of the circle. All right, so by using pi equals 3.142, find angle BOD in radian. Okay, so first of all, BOD. We know if this is 5, this is 10, we can use a simple Pythagoras theorem to find the length OB if you want. Okay, but the first thing is we want to find this angle. So let me redraw this triangle for you, right? Let me draw over here. So this is now 5. It doesn't look like 5. Maybe I make it a bit shorter. This is a bit longer. This one is 5. This is O. This is B. Well, the perpendicular distance here, you can call it maybe D, right? So we know this is 10, right? In coordinate system, 5 to the right, 10 up. So my angle BOD, we can use tangent, because tangent is a ratio of opposite, this is my opposite, over adjacent. Now let me label for you. This is my opposite, this is my adjacent, this is my hypotenuse. So we use tangent. So tangent BOD is 10 over 5, which is 2, right? So to find angle BOD, notice we can just change our calculator mode to radian, right? You know you can do that. Shift mode, change 4 to radian, shift tangent, 10 over 5. 10 over 5 is just 2, or you can just type 2. And your answer in radian is 1.107. This is 1.107. Now, some people, they change to degree. They change this to degree. They use degree mode. So I don't recommend this, because if you use degree mode, right, then you got to convert to radian. And the conversion of radian, we have to multiply with pi over 100t. Now, the problem is, most of the time we have to use 3.142. 3.142 is a rounded off value. It's not the accurate value. And we have no choice because the instruction asks us to do that, right? If you use a calculator, pi is actually more accurate, but we are not following the instruction, right? So it's not accurate. So that's why I would recommend that you straight away change your calculator to radian mode, shift tangent, in this case is 2, and get your answer straight away in radian, right? And always give your answer correct too for significant figure. All right. So next one, we're going to find perimeter. Well, perimeter is rather simple. I just need to find the length of OB first. Yeah, OB we can find from here, which is what? 5 squared, 10 squared, or you can say 10 squared, 5 squared, square root, which is square root 125. I'm going to leave it 125 first. So your radius is square root 125. So this length also square root 125. 125, right? My 2 looks ugly, 125. So what I need is to find the length of arc of BD, right? So your perimeter, sorry, let me do it here. Perimeter consists of 2 times of square root 125 plus this square root 125. I need to mark is your radius. Remember, to find length of arc, we use S equals R theta. Your R is your radius, theta is your angle. I know my radius is square root 125. My angle theta is 1.107. Let's just put them together. 2 square root 125. You plus with square root 125, multiply by 1.107. There you go, 34.74. Yeah. You want to give more decimal point, not a problem. 34.737. But for significant figure is good enough. Okay. All right. C, area of the major sector. Be careful. They use the word major sector. Yeah, major means the bigger sector, not the minor sector. Major sector BOD, the bigger one. Now we know this is 1.107. When you take one whole turn, in degree total angle is 360. In radian is 2 pi. So to find the bigger major angle, if you like, we need to minus 2 pi minus 1.107. So my area is half r squared theta, 2 pi minus 1.107. Be careful, when you use a pi, please use 3.142. Okay, let me show you here. So let's take half. Now the good news is the square root 125 square is just 125. So you don't need to type the square root. Yeah, you know, you take the square root, your square root is still the same. Please use 2 times 3.142 minus 1.107. There you go. My answer is 323.6. Again, you can give more decimal point. You can give 323.56 if you like. Yeah, 323.6. 323.6. This is for significant figure, right? Okay, question number 10. This is Form 5, Chapter 2, differentiation. Previously, circular measure is Form 5, Chapter 1. So first part, very simple. Find dy dx when x is 2. So we just differentiate dy dx. You bring the power down. 3 times 2 is 6. Copy x. Differentiate minus 2x. You get minus 2. Differentiate 3. You get 0. Then we substitute x with 2. My dy dx is 6 times 2 minus 2. 12 minus 2. Answer is 10. Okay. B, I'll do it here. Find the percentage of approximate change in y in terms of m when x changes from 2 to 2 plus m. M is a small value. Okay, well, this is a small change approximation question. So you may have a curve like this. Let me explain to you. Let's say the curve like this. Originally, your x is 2. Your x increases by a small value, right? So because it's too small, right? So it's actually almost on the curve. Sorry, looks a bit up. So when your x increases from 2 to 2 plus m, well, you have what we call a delta x. Delta x is m, the small change in x. In this case, your delta x is m. 2 to 2 plus m, the difference is m. Well, when your delta x is small, we always make one assumption. The assumption is that your delta x, delta y over delta x is approximately the same as the gradient tangent at that point. Well, the gradient tangent at that point, let me just highlight for you this line is this line here, is a red line, right? Well, the gradient tangent at this point, we actually got it from the first part, which is 10. dy dx when x is 2, dy dx is 10. So your delta y is what we're finding, the small change in y or approximate change in y. Your approximate change in x is m, this is 10. So when you times it over, this is 10m. Now, the next thing is, because you're finding approximate change, okay, maybe I just continue here. We need to find what is you're finding a percentage of approximate change, right? We need to find what is your initial y. You can't find percentage of change if you don't know what is the initial value of y. So we basically sub x equals to 2 inside your original function here. So you got 3, 2 square minus 2 times 2 plus 3. This is 12 minus 4 plus 3 gives us 11. So we can call this initial value of y. Initially, y is 11. Over here, 11. So now your y actually increases by delta y. In this case, your delta y is 10m. Can you see from here? Delta y is over here. All right, so to find the percentage of change in y, you can write short form like this. You can just write word percentage of change. We must take delta y divided by initial value of y. You can write this as yi. Yi means initial value. All right, divided by yi times 100. So this is 10n divided by 11 times 100, not the nicest value, right? So we take 10 divide 11 times 100, you get 90.91, right? So we have to write in terms of m, 90.91 m. Yeah, so that's your percentage. We can put a percentage symbol over here, right? Okay, next question is question 11. Okay, so this question is a bit long. Yeah, we have to use differentiation and integration. Okay, so first of all, the curve diagram shows the curve y equals x squared plus 3, where AC, it intersect AC at point B. So the gradient of the curve at B is 4. Equation straight line AC is given as this. So find the area shaded region B. Okay, to find the area shaded region, number one, we need to find the coordinate point B. Now the question already say that the gradient of the curve at B is 4 here. So I think we can differentiate dy dx. Remember, dy dx is gradient tangent gradient curve. So we differentiate this, you get 2x, differentiate 3, you get 0. So at this point, the gradient is 4. We sub your x coordinate, guys. Your x coordinate is k, so k is just 2. All right. But that's not my answer. I need to find area. So I know k is 2. When k equals to 2 here, k equals to 2 here, I can sub inside either here, first one, second one, maybe I sub inside. There's a y equals to x, or I think I sub inside here. When x equals to 2, your y is 2 squared plus 3, it gives us 7. So this is 7. Now, why do I need to do this? Because I want to find area shaded region P. And to do so, I need to take this trapezium. I need to minus this integration. Yeah, trapezium minus this region Q. Well, I know this is 7. I know this is 2. I still need to find the height. But it's not difficult. We know from here, if I add y-axis, x is 0, or we can say y equals mx plus c. Your c is 9. Therefore, point C is 9 here. So this is 9. Now, my area is now, let me just, I think it's better for me to continue here. So you can see area of trapezium is half sum of parallel side 9 plus 7 times height minus area of integration. This curve we can integrate. And the formula is 0 to 2, integration 0 to 2, x squared plus 3 dx. That will give us area of shaded region Q. Okay, so let's continue. This one we can cancel. It will give us 16. 2 and 2 I can cancel. 9 plus 7 is 16. As we integrate this, right, integrate x squared, you should get x cubed over 3. Integrate 3x, you get, integrate 3, you get 3x. This is 0 to 2. We substitute, put 2 inside, 2 power 3. I write 8. Then you have 2 times 3 times 2. The 0 is a simple thing. You can just cancel them off. Okay, so this one we can add them up. This is 16. 8 over 3 is 2 over 3. You plus 6. You get 8, 2 over 3. So when you subtract, you get 7, 1 over 3. Okay, one thing, you can always double check your integration using a calculator. I hope you already know about this. If you have this calculator, right, even the black one, this one, the black and white as well, you can do that. All right, so we can just use this integration button, press alpha x, you square it, plus 3. Lower limit is 0, upper limit is 2. Just counter check. This will be 8 over 3. Then you take 16 minus answer. There you go. 7, 1 over 3. So we know answer is correct. Yeah. But of course, you need to know how to integrate as well. Integrate and substitute. Okay, lastly, you're supposed to find volume when the region Q is revolved 360 degree about the y-axis. So when you revolve 360 about y-axis, about the x-axis, this is what you get, right? The formula is for volume is integrate pi y squared dx. So you're going to sub your y inside, square it dx. Your lower limit is 0, upper limit is 2. Okay, so we can't integrate this directly. Remember, if you want to use composite function, this is the integration of composite function. right? We have to do what? Copy the bracket, increase the power by 1, divide by the increased power, and differentiate inside. So this formula is valid only for linear term. The moment you have an x squared is non-linear, we can't use this, right? So we need to expand the bracket, right? So expand the bracket, this will give us, take out the pi, 0 to 2. I'm going to use a plus b squared. I hope you know how to expand quickly. A squared plus 2ab b squared. My a is x power 2. I squared it becomes x power 4. 2ab is 2 times x squared times 3, or we can think 2 times 3, 6. 6 times x squared is 6x squared. 3 squared gives us 9. Now let's integrate this. This is going to give us x power 5 over 5. This will be x power 3. 6 divided by 3. This is going to give us 2. And this is 6x. Lower limit 0. Upper limit 2. Now let's sub inside again. Put 2 inside. I got 32 over 5. This is 2 power 3 is 8. 9 times 2 minus 0. Okay, can't do mentally? Use your calculator. Right, so 32 over 5, you add with 16, this is 16, and then you add with 9 times 2, 18. There you go, my answer is this. Yeah, actually you can leave your answer as 202. You can see just now 202 over 5. But for me personally, like mensuration like area, volume, it actually makes better sense if you leave the answer as mixed number. So we know this is 42 over 5 pi. So it's like slightly more than 40 pi, right? So, but it's okay to leave your answer in this. In fact, some marking scheme will give answer in this form. Yeah, so it doesn't matter. So unit cube. And again, if you want, you can use your calculator to integrate. You can even integrate this directly at alpha x squared plus 3 bracket square, lower limit 0, upper limit 2. Yeah, you can do that. And you still get the same answer, right? Well, this is quite a good trick to know. Okay, question number 12. The first part is, this is from chapter 4, from 5 chapter 4, permutation combination. The first part is permutation. The second part is combination. Usually that's the case in exam, right? Okay, so first part, how many ways are there to sit, SIT, 3 boys and 4 girls in a row of 7 chairs if 3 boys are sitting next to each other? Okay, so this is quite easy. Since I got space, I'm going to write over here. I'm going to put the 3 boys in a row. I've got 4 more girls. All right. So the idea is to tie the 3 boys together in a block. So first of all, how many ways to arrange 3 boys in a row among themselves? Answer is 3, 2, 1. Right. Then I tie them together as a block like this. Yeah, they are good friends. Wherever one goes, the rest will follow. Yeah, they're together. So I still got 4 more girls, right? 4 more girls. Now, when you have a block with 4 more girls and I want to arrange them in a row, that means there are 5 blocks now. The block of 4, 3 boys plus 4 girls, there are 5 blocks. So how many ways to arrange them? 5, 4, 3, 2, 1, or we say 5 factorial. So the number of ways to arrange them is now 3 factorial times 5 factorial, which gives us 6 times 120, 720. Yeah, again, if you're not sure, it's okay, calculator, right? So 3 factorial times 5 factorial, can you see? Answer is 720. All right, for B, in the box, there are 10 balls, each are different color, each with different color. These balls are divided among 2 boys, where each of them get at least 4 balls. So find the number of ways the balls can be divided between the 2 boys. Okay, so I'm going to call this boy number 1, first boy. Okay, first boy. And this is second boy. Okay, we have 10. Yeah, and there are a few cases you consider. Case number 1, you must get at least 4. So if you have 10, the first one will get 4. Second one will get 6 because the total is 10. Now, we can also say first person get 5, second person get 5. Or we can say the third one, third case, the first person gets 6, second person gets 4. So there are 3 cases, right? So let's just put them together. Okay, so remember, we have 10 balls to begin with. So the first boy get to choose any 4. If you've taken out 4, you're left with 6. The second boy got no choice, have to take the remaining 6C6. By the way, 6C6 is 1, and if you don't want to type out, it's okay one. Yeah, it's 1. Okay, second one. The first boy get to choose first, then choose 5. The second boy got no choice, have to take the remaining 5. Now, the third one is the first boy choose 6, second boy get the remaining 4. So we will just add them up, right? So it's 10C4, 10C4. Okay, now 6C6 is 1. If you don't want to type, it's okay. We just plus the next one, 10C5, and the next one, 10C6. Okay, so the answer is 672. Now, I know a lot of people will be thinking, this is not fair. You know, the first boy gets to choose all. How about the second boy? Well, the order will be taken care of itself. For example, let's say you have A, B, C, D, E, F. This is F, G, H, I, J. There are 10 here, okay? So whatever the first boy get, the second boy get the rest. For example, the first boy may get this. The rest will be given to the second one, right? For example, 4 and 6. Now, he can also get, let's say, for example, this one, this one, this one, and this one. The second boy will get the rest. So it's fair system, right? Whatever he gets first, the other guy will get the rest. Whatever he didn't get the first, the other boy will get, the rest, right? So it's actually, it takes into consideration all the different combination, right? So you don't have to reverse the order, yeah? Okay, moving on to question number 13. Okay, the first part, this is from chapter 5, probability distribution. The first part is a binomial distribution. The probability that Jessie win a badminton competition is 1/5. If she participates in n competition, the probability that for Jessie to win once is 16 times the probability that losing all. Okay, find the value n. Okay, so first of all, we know this is a binomial distribution, but if you don't write this, it's okay. This binomial, this is a notation of how to write binomial. We don't know what's your n. We know the probability is 1/5. So the probability that she wins she wins once is equals to 16 times the probability that she wins none. So what we can do is, number one, we can say NC1, right? Your P is 1/5, power 1, your Q. Okay, if you're not sure, the formula is given as this, NCR, P power R, Q power N minus R. Q, by the way, is P 1 minus P. Yeah, Q is 1 minus P. So we can take 1 minus 1/5. I got 4/5 power N minus 1. This is 16 times of NC0. Your P is 1/5. Your Q, this is power 0. Q is 4/5 power N. Okay, so the next thing is, how do you simplify this? Now, I'm not sure if you know about this. NC0 is 1. NC1 is N, right? You can actually derive this, like, NCR is N factorial, N minus R factorial, R factorial. So NC1 is N factorial, N minus 1 factorial, 1 factorial. Well, N factorial is N times N minus 1 factorial. This is N minus 1 factorial. 1 factorial is 1, cancel. This is N, right? So I hope you don't need to use this. We know NC1 is 1. You're not sure, you can even try using a calculator, right? Like 5C1 is just 5. Okay, so this will give us N. Now, 1/5, I'll just keep this first, right? This is 4/5 N divide 4/5. This is 16. NC1, like I said, is 1. And anything power 0 is also 1. So I'm left with this. So what I need to do, guys, is to cancel out this one, right? 4/5 power N. Now, I purposely divide this up. N 4/5 power N minus 1 is 4/5 power N, divide 4 power 1. So I just, we can actually bring it over, or even you can invert as in, this is N times 1/5. You invert it, becomes, this one becomes 5/4. The result is 16. Okay. Now what do I do? Well, we can cancel this and this, multiply the 4/6, right? This is 4/5. Good. So your n is 4 times 16, which is 64. Okay, so done the first part, right? Quite long. This is Roman 1. Roman 2, calculate the mean. Okay, now remember mean for binomial is NP. Yeah? This formula you need to know is given. N is 64. P is probably a success. In this case, 1/5. 64 divided by 1/5 is the same as 3.2. You're not sure, you can use a calculator. Divide by 5. Yeah, 12 point, I say wrongly, 12.8. 12.8. Okay. Now, this is part A. Let's move on to part B. Part B is a normal distribution. Okay, normal distribution, the first part, modulus z more than 2.159. Now, we know by now, when you modulus something, let's say I give you a simple number, modulus z, let's say more than 1. When you open up modulus, there is a negative and a positive. The negative one, we change the symbol. The positive one, we maintain the symbol, right? So in this case, your Roman 1, you need to break it up to z less than negative 2.159 and z more than 2.159. Now, if you don't want to write this, it's okay. Yeah, it's okay. I can just use the diagram. We know modulus more than is this 2n. That means we are talking about a diagram like this. 2.159. This is negative. This is the left-hand side. This is the right-hand side, 2.159. So it's actually 2 times of z more than 2.159 because they are actually symmetrical. Yeah, they are the same. So here we can use a mathematical table or calculator, but seriously, I would highly recommend that you use a calculator. It's so much easier. Well, depending on which calculator you're using. If you're using this one, yeah, you change your calculator mode. Number 1 to stats. You go to AC. You press Shift 1 for stats, 5 for distribution, press 3 for R. Remember, in your calculator, R is your upper tail, right? Your mathematical table, we use Q. This is your mathematical table, we use Q. Q is your upper tail, right? But in calculator, we use R. So type in your calculator, 2.159. Guys, I got 0.01 0.0154, but please multiply by 2. So I'm going to write here 0.0154 u times with, sorry, I leave it here, times 2, 0.0154. I times 2, my answer is 0.0308. Okay, 0.0308. Now you can also use a mathematical table if you want. 2.159, you can see 2.1. Let me show you here is, okay, let me move this up. Okay, 2.159. You need to subtract 4 from the last digit. Yeah, when you subtract 4 from the last digit, you get 0.0154. Yeah, it's the same thing, but it's a bit slower. Yeah, calculator, obviously, it's a lot faster. Okay, so the first part is modulus more than. Second part is modulus less than. So let me explain again, modulus less than. When you open up modulus, there's a negative and there's a positive. The negative one, you change the symbol. The positive one, you maintain the symbol. So when you combine it, it's between -1 and 1. Okay, but this is for 1, but this case is 1.684. So I'm just going to write over here, Roman 2. This is z between -1.684 and 1.684. Okay, also remember, in normal distribution, there's no difference between a less equals and less than, right? There's no difference between this sign because the probability of z exactly 1.684 is just 0. Remember, this 1.684 can be here. The probability for normal distribution is based on area under the graph. Area under the graph for one thin line is just 0. Yeah, it's just one thin line. So there's no difference between less equals and less than, right? So I'm just going to write this. And based on the diagram you want, you can draw this. This is in between -1.684 and 1.684. So this is an in between value. In this case, we have to use 1 minus, yeah? 1 minus the upper tail here and the upper tail here. But since they're the same, I'll take 2 times of z more than 1.684. Okay, the upper tail for 1.684, use your calculator, shift 1, 5 for distribution, 3 for R, 1.684, and I got 0.0461. 0.0461. So 0.0461. A 4 decimal point would do, because if you take 4 decimal point, it's the same as what you get from the mathematical table most of the time, not all the time. 0.461. Okay, there you go. 0.9078. 0.9078. Okay. Okay, let's move on to question 14. Okay, there are 2 parts to it. This is a trigonometry. The first part is solving this equation. So we can start off by changing the one with square, or we change the sign to x. Okay, in this case, maybe I change the sign to x first because I can't see, what is the outcome. Remember, if the equation has cos square and sine, then probably you use change the cos square to 1 minus sine square using the basic identity. But in this case, I don't know what is this sine to x. I change this first to 2 sine x cos x, right? Remember, this formula is given. Sine 2a is 2 sine a cos a. Well, I have a common factor here. My common factor is cos x. So when you take out the cos from the cos square, you're left with 3 cos x, and this is 2 sine x. The result is 0. Now, then we take our cos x, we let it be 0, and take the second one, 3 cos x equals to, bring this over, minus 2 sine x. Now, we know sine divided by cos will give us tangent. So, we bring this cos down. 3 over 2 is sine divided by cos. So, this is tangent x. So, what we need to do is to solve these two, right? So, first of all, for cos x is 0, for me, I will use the graph. The easiest way to solve is using the graph. We know the graph of cos looks like this. It goes down, up, here. Your cos x is 0 here and here when it is at 90 and 270, right? The second one, for tangent x equals negative 302, you need to use a reference angle. Okay, so I'm going to use my calculator. Please ensure it's in degree mode because you want your answer in degree. So we press shift tangent 3 over 2. This is 56.31. Yeah, that is your reference angle, 56.31. Okay, now your tangent, as you can see, is positive in quadrant 1 and 3. But this is negative, so we don't want this. We want answer in quadrant 2 and 4. I hope you still remember your ASTC. Tangent is positive 1 and 3, negative in 2 and 4. Since this value is negative, so we should take quadrant 2, 180 minus 56.31, and quadrant 4, 180 plus 56.31. Sorry, quadrant 4 is 360 minus. Yeah, 360 minus 56.31. So my answer is 123.69. All right, that is the first answer. Second answer is 303.69. There you go. 2 answers for the second one. First one, you have 2 answers. Second one, you have 2 answers. Total, you have 4 answers. All right. Let's move on to part B, trigonometry. Yeah, this is your Form 5, chapter 6. Okay. Solve this simultaneous equation. Okay, so first of all, we can bring the 2 down. We have sine x plus y equals 3 over 2. And the second one, sine x minus 1, 1 over 2. So when you use your calculator, here we have to use shift sine 3 over 2. We're going to find our reference angle. Okay, so 3 over 2, this will give us 60. Now, the problem is we know sine is positive in quadrant 1 and quadrant 2, right? Here they say x and y are acute angle. But if x and y are acute, when you take x plus y, it can both are acute angle. It is possible for you to get obtuse angle, right? So this one can be, if x is acute between 0 to 90, y is acute between 0 to 90. So x plus y can be between 0 to 180. So that's why in this case, we have to consider quadrant 1 and quadrant 2, two answers. So this one, when you use your calculator, I know my reference angle is 60, but it can be 60 or it can be, let me just write here, 180 minus 60. 180 minus 60 gives us 120. Yeah? So x plus y can also be 120. So there are two equations to consider, right? But for x minus y, it's quite straightforward. If you take x minus y, definitely it's not going to be more than 90. X minus y is definitely less than 90, right? Between 0 to 90. So when you use your calculator, shift sine 1/2, this will give us 30, yeah, 30 degrees. So I can write x minus y equals to 30. So the problem is we will have 3 pairs of equation to solve. Okay, we need to solve equation 1 and 3 and then 2 and 3. So let's do 1 and 3. Yeah? So 1 and 3, let me do it here. 1 plus 3. X plus x is 2x. 60 plus 30 is 90. First answer, x is 45. So when you sub inside equation 1, if your x is 45, your y will be what? Your y will be 60 minus 45, y is 15. Okay, then we have to solve equation 2 and 3. Again, I plus together. X plus x is 2x. Y plus negative y is 0. 60, this is y. 120 plus 30 is 150. 150 divided by 2, 75. So once you got 75, you just sub inside, let's say, equation 2 now. This is, I'm solving equation 2 and 3. So 75 plus y is 120. My y is 120 minus 75, 45. All right. Okay, and the last question, this is a solution triangle form for chapter 9. Now, most of the time, this question will come in paper 2. It is unlikely to come paper 1. It's usually a section C question in paper 2. Okay, anyway, now the first thing is I want to find angle ACB. If you look at the diagram, all the information are given, but they didn't label this 15. BC is 15 over here, and angle ADE is 120. So I don't need 120 for now. What I need for the first part is angle ACB. ACB, that means this angle. So we know the length of all three sides. This is 18, that is 15. And if you take 16 plus 8, this is 24. Your length of AC is 24. So when you're given length of three sides and you're finding an angle, in this case, you're finding angle ACB, we can use cosine rule. Now remember, cosine rule is given as this: a square equals b square plus c square 2bc cos a. But if you're given length of three sides, normally I like to rearrange the equation so that I can just sub in and calculate more quickly. It's kind of difficult. You put all the figures in and then you rearrange it later. So I'm going to bring the 2bc cos a over. All right. So, and then I put b square plus c square minus a square. Imagine I have a bc in front, 2bc in front. I'm going to divide it 2bc. Yeah, I hope you've seen this. This is a rearranged form of cosine rule. Now, since I know I'm finding cos angle ACB, your B and C will be these two lengths, 15 and 24. Your A is the opposite length, which is 18. You divide by 2 times 15 times 24. Okay, use your calculator, right? 15 square plus 24 square, you minus 18 square. All right, 18 square, divide by 2 times 15 times 24. So whatever I get, I shift cos, answer equals. Do it one shot. Please don't do one by one. The more steps you write, the more inaccurate you will get. After all, in exam, this is 2 marks. One for using the formula, one for the final answer. 48.51. So I'm going to write here 48 ACB 48.51. Okay, I've got this angle already. So the next one, the length of DE. DE. Well, DE is this length, right? The opposite side. I really know this is 48.51. I know this is 60. So here we should use sine rule. Yeah, sine rule comes in pairs. So if you know the length of 8 cm, I need to find this angle DEC. This is part 2, part B, which is 180 minus 60 minus 48.51. Okay, 120 minus, I can just do 120 minus 48.51. It gives me 71.49, right? So if it's 71.49, I can now use sine rule. Okay, I'm finding DE, right? So we say DE, divide opposite angle. We write sine 48.51. Then the opposite side is 8. We divide by sine 71.49. Whatever I get, I multiply over. Okay, so see, 8 divide sine 71.49. Okay, calculator must be in degree mode. Then you multiply by sine 48.51. Okay, whatever I get, there you go, 6.319. 6.319. Okay, lastly, find the perpendicular distance from B to straight line AC. Perpendicular distance from B to straight line AC is this. Okay, actually, I don't need anything else because I know that if this BC is 15, this is 90 degree, right? We can call this perpendicular distance, let's say I call it N. We know this angle, 48.51. We can just use sine 48.51, not even sine rule, no need to use sine rule, just use a basic SOHCAHTOA. Sine of this is Bn over 15, so your Bn will be what? Take sine 48.51, all right, multiply by 15, there you go, 11.24. Yeah, 11.24. Okay. All right. So that's the end for discussion for this paper 1. I hope you learned something from this video. Thank you for watching.